Logic circuits. Several logic gates can be connected to produce an output based on specific criteria, with logical reasoning represented through Boolean expressions or logical circuits. Boolean algebra is a specialized algebraic system that deals with Boolean values, that is, values that are either true or false. This can also be represented using the binary numbers 1 and 0. Input and outputs of logic gates can be represented using Boolean variables, such as a and b. If an input A passes through a NOT gate, the output becomes not A. Here we can see the operator symbol for the NOT gate. Given two inputs A and B, if these inputs are passed through an OR gate, the output can be represented as A or B. Here we can see the operator symbol for the OR gate. Given two inputs A and B, if these inputs are passed through an AND gate, the output can be represented as A and B. Here we can see the operator symbol for the AND gate. To derive the Boolean expression from a logic circuit, we find the output of each gate. For our first gate, we have an output of A or B. The second gate is a NOT gate and will result in an output of NOT C. Finally, these outputs are fed into the final AND gate, resulting in the combined Boolean expression X equals A or B and NOT C. A truth table can then be derived from the logic circuit and/or Boolean expression. This gives us all possible outputs for the circuit, depending on the inputs fed into it. The number of rows needed can be calculated using the number of inputs, using the formula 2 to the power of I. So, if we have 3 inputs, we require 2 to the power of 3 or 8 rows. The number of columns can be calculated by adding the number of gates in the circuit with the number of inputs. A circuit with 3 gates and 3 inputs would require 3 plus 3, or 6 columns. So, the truth table for the Boolean expression X equals A or B and NOT C has 3 inputs and 3 gates. Thus, we require a truth table with 8 rows and 6 columns. We then write down in the header of each column our inputs from left to right, followed by the outputs of each gate, ending in the output of the final gate. Then we fill in every possible combination for our inputs. This can be done easily by first filling in the input furthest to the right, in this case C, with alternating zeros and ones. For the next input to the left, we double the amount of zeros and ones. We keep doing this until we reach the last input on the left. So, in this case for input C we have a pattern of 0 1 0 1 0 1 0 1. For input B we have 0 0 1 1 0 0 1 1. And finally for input A we have 0 0 0 0 1 1 1 1. We can find the output depending on the gate found in each of the headers. So, for our first output we have A or B, thus, we only have a 1 when A or B are 1 or if both are 1. The remaining rows can be filled with zeros. For our next column, NOT C, we simply reverse each value of C, resulting in 1 0 1 0 1 0 1 0. Finally, we take the outputs of A or B and NOT C, and pass them through an AND gate, resulting in a 1 only when both columns have a 1. The rest of the rows can be filled with zeros, to complete our truth table. We can also derive the logic circuit when provided with the Boolean expression. First, split the Boolean expression into single gates, starting from the most inner expression, moving outwards until you have covered all gates. For this circuit, the first gate is a NOT gate and it takes as input A, and outputs NOT A. Next we have an OR gate that takes as input B and C, and outputs B or C. This output is then passed through a NOT gate to produce NOT B or C. Finally, we combine these outputs and feed them as inputs into an AND gate. This gate produces the output NOT A and NOT B or C, which is in fact our expression. To complete the circuit, join all the gates in the correct order. First, we pass the input A through the NOT gate to produce an output of NOT A. Then we pass the inputs B and C through the OR gate to produce the output B or C. This output is then fed as input into another NOT gate to produce the output NOT B or C. Finally, we take this output, together with the NOT A output, and feed them as input into our final AND gate, resulting in the output NOT A and NOT B or C, which completes our circuit. Thank you for watching.